Hey everybody, welcome to Geometry, section 10.6 and 10.7. We're going to cover them both at the same time. They're so closely related, I figured why not, over areas and circles. So by the end of this lesson, you should be able to understand and use the vocabulary related to circles, correctly label circles and arcs. You should be able to measure arcs. You should be able to find circumference and area of circles. Find the lengths of arcs, and find the area of sectors. That's a lot. So let's just jump right into it. First off, if we're talking about circles, you need to know what a circle is. And I'm sure everyone knows, well, it's a big old round thing. Yes, you're right. But much like anything else in geometry, we have to label it. So there's lots of points on that circle, but there's one point that's the most important of them all, and that's the point in the center. So there's our center point. I'm going to go ahead and give it a label. Let's call it point P. And when we do that, we label the circle by that center point. So I would call that circle P. And you can see the label for it right here. It's just a little circle with a dot in front of it, so it's not confused with an O. It doesn't look like OP, all right? But it's circle P. And that's how we would label that circle. Some other things you need to know about a circle. The length from the center out to the edge is called the radius. Likewise, the chord that goes across the center of the circle is called the diameter. You probably know this already, so I'm not going to belabor the point. However, if I were to draw two radii, so here I have radius PA and PB, what that happens is point A and point B, if I were to connect those along the outside, or if I were to make that angle with point P, that's called the central angle. And so angle APB is the central angle. So an angle whose vertex is on the center of the circle. Okay, now that's very similar to what the central angle in regular polygons that we've already covered. So not a big deal there. Angle APB is a central angle. Another vocabulary word you need to know is circumference. So the circumference is just the distance around the circle. So if I start at point A and go all the way around and I were to measure that length, that would be the circumference. Another vocabulary word to know is arc. So if I have point A and point B, and then I connect those along the edge of the circle, that's an arc. So the technical definition of an arc is a portion of the circumference. So here we go. We can go ahead and outline it right there. That red thing from point A to point B is an arc. Now with a segment, and we covered this back in semester 1, you have your two letters and then you have the little line over the top. Well, we can't use the line because it's not really a line that's connecting point A and point B right now. So what we do is we say arc AB and we label it like that, where we have AB and then a little arc over the top. Okay, so it looks very much like segment AB, except we don't have a segment up there, we have an arc. Now something that you need to know is that arc AB is a minor arc. A minor arc is any arc that's less than 180 degrees. So 180 degrees is exactly half the circle. So any arc that's less than half the circle is a minor arc. A major arc is an arc that's more than 180 degrees. So if I were to go from point A to point B but go the other way around, that's a major arc. So here we see that. But let's talk about how to label a major arc. If I just said arc AB, then I would assume the shortest distance possible. But if I want to go the long distance around, I'm going to label it arc ACB. And you can see that right here. Now the reason I do that is because I start at A and I go around through point C and end up at B. So that's a good way of labeling it so that everyone knows you're talking about the major arc. A major arc should always have 3 letters, and a minor arc should have 2 letters. Okay? Next thing to know is a semicircle. A semicircle is basically just half of the circle. So if I said, an arc that's exactly 180 degrees. So here I've got arc BD. So I start at point B and I end up at point D. But if I had arc BD, I could also say, well, I start here at B and I go the other way around to point D. So if I want to make the distinction, this one I would call it BCD, just to show that I start at B and I go through point C and I end up at D, much like a major arc. Okay, if I wanted to do the other one, I would call this arc BAD. Okay, so it starts at B, goes through point A, and ends up at point D. Next thing I want to talk about is how to measure an arc. So there's going to be two ways that we quantify an arc, one by its measure and one by its length. So let's talk about measuring an arc first because it's easier. So here we've got a circle. We've got two radii, and I've got point A and point B on the edge of the circle. Now I see that this central angle is 45 degrees, and this is going to be so easy. It's like the easiest thing we've ever done. The measure of an arc, so the measure of AB, is also going to be 45 degrees. So whatever the central angle is, the measure of the arc is the exact same. Okay? So here I would say the measure of arc AB is 45 degrees. Okay, and that's exactly how I would write that. Okay, now if I were to do the major arc, so starting at point A, going all the way around to point C, and then ending up at point B, here's what I would do. I would say the measure of arc ACB is 315. Because if A from A to B is 45, the major arc is the rest of the 360 degrees. So 360 minus 45 is 315. Now let's go ahead and use this idea on a couple example problems. Okay, so let's use this diagram here to figure out these missing quantities. So question 4 says, what's the measure of arc RS? So from R to S, well, that central angle is 60 degrees, so I know that arc RS is also 60 degrees. Number 5, RPS. So that means I start at R, go around to point P, and then end up at point S. So that goes all the way around like that. So it starts at R, ends up at S. Well, that's the full circle except for that 60 degrees. So if I do 360, subtract the 60, that just gives me 300. Number 6, the measure of arc PQR. So it starts at P, goes through point Q, and ends up at point R. Well, that's exactly half of the circle. That's a semicircle, so that's 180 degrees. Then the measure of arc QS. So that means we start at point Q and we go to point S. So that's the 40 degrees up there, as well as the 60 degrees that we just found. So arc QS is going to be 100 degrees. All right, almost done here. The measure of arc QSP. So that means we start at Q, go around to point S, and then end up at point P. So that's quite a big arc there. So I know from R all the way around to P is 180. So I can just take that 180 and add that 40 to it, and that would give me 220. Last thing, the measure of angle QTR. So QTR, so that's this angle right here. So because arc QR is 40 degrees, that means that central angle is also 40 degrees. So there we go. Not too bad, a little bit of mental acrobatics, but for the most part, pretty easy stuff. I hope you agree with me. Okay, so now let's talk about how to find the circumference of a circle. Now, I'm pretty sure you've done this in previous math classes, so I'm not going to spend a whole lot of time on this. You should know that the formula for circumference is C equals 2 pi r. So the circumference is 2 times pi times the radius. So here we have an example where we have a circle with a 6-inch diameter. Now, that 6 inches is the diameter, not the radius. So we can find the radius just by cutting it in half. So we know that our radius is 3. So all we got to do is just take that 3 and plug it into the formula. So 2 pi r becomes 2 pi times 3. And then 2 times 3 is 6. So our circumference is 6 pi. Now, I'm fine if you leave it like that. Depending on what the instructions ask for, they might say don't round, so leave it as an exact answer, in which case 6 pi is your answer. If they say to round it, go ahead and use 3.14 as your value for pi. Or some of you might even have on your calculator a pi button. So if you use that pi button, that's going to be much more accurate. Well, not much, but it'll be more accurate than just 3.14. So if you use 3.14, you could get 18.84 inches. So that means if I were to take a piece of string and wrap it clear around that circle, it would take almost 19 inches of string. Now, I want to use that idea to figure out the length of an arc. Remember, I said that there were two different ways to quantify an arc. One is with its measure, which we've already done, and that's pretty easy, and that's measured in degrees. When we talk about arc length, that talks about the actual length. If I were to take a piece of string and wrap it around that arc, how much string would I have? Okay? So let's go back to this example here. Let's figure out the length of arc AB. So what I'm going to do is, I told you that an arc is a portion of the circumference. Well, how much of the circumference is it? Well, we can figure out what fraction of the circumference it is by taking the arc measure, which in this case is going to be 45, and divide it by 360, which is the full circumference. All right? And that will tell us what portion of the arc it is. So then what we do to finish up this proportion is we'll put the arc length on top and then the circumference in the denominator. So if what I said didn't make any sense right there, just get this formula. The measure of the arc over 360 is the arc length over the circumference. So the partial over the whole equals the partial over the whole. All right? So let's go ahead and take the values and plug it in for this. So the arc measure we just said was 45, and the 360 stays 360. And then the arc length, that's what we're trying to find, so we'll call that x. And then the circumference, well, I can take that formula, 2 pi r. Our radius is 12, so I can plug that in. And then after I do some calculation, I get that the circumference is 24 pi. So I can go ahead and plug that in to our ratio. And now I've got a ratio that we can solve, or sorry, a proportion that we can solve. Do a little bit of cross multiply. Okay, yeah, so let's make some room first, and then we can go ahead and cross multiply. So 45 times 24 pi is 1,080 pi, and that equals 360x. Let's get x by itself by dividing by 360, and I get that x is 3 pi. So again, if I were to take a piece of string from point A and wrap it around to point B, that would be 3 pi, whatever unit, long. And again, if you wanted to use 3.14 as your value for pi and go ahead and just figure out an actual number, you could do that too. Let's go ahead and take a look at some examples and work on this a little bit. Okay, so remember our proportion. The first ratio deals with the angles. So it looks like in problem number 1 here, the angle that I'm dealing with is going from here at the top all the way around to right about here, which is 315 degrees. So 315 degrees over 360 degrees equals the arc length, which is what I'm trying to find, over the circumference, which is 2 pi r. So because my radius is 11, 2 times the radius is 22 times pi. So there's my proportion. Now I can go ahead and cross multiply. I can take 315 times 22 pi. And I get 6,930 pi. Equals 360x. And then just divide both sides of that equation by 360. And I get 19.25 pi. And that's the length of my arc. Now, if I wanted to go ahead and figure out what that was as a decimal, times 3.14. Okay, it says round to the nearest tenth, so I'm glad we did that. So that would be 60.445. So that arc would be 60.4 feet long. Okay, let's go ahead and do the same thing on the question number 2. Let's choose a different color. All right, so we'll go ahead and do our angles first. So the partial angle, which is 270, over the full 360, equals our arc length, which we don't know, over the full circumference, which if our radius is 13 feet, so 2 pi r, that's going to make 26 pi for the full circumference. Now, if you wanted to, sometimes it helps with calculation. If you don't like working with those big numbers, you can reduce the 270 over 360, which those both reduce by 90 and make 3/4. And doesn't that make sense? Because that arc looks like 3/4 of the circle. So when I cross multiply, I get 78 pi equals 4x. And then 78 divided by 4, I believe that is 19.5. So that arc length is 19.5 pi. Again, the instructions want it as a decimal, rounded to the nearest tenth. So times 3.14, I get 61.23. So 61.23 feet. Okay? Hopefully you find using this proportion not too bad. Okay, just remember it's the partial over the whole for the angles, and then the partial over the whole for the actual lengths. Okay? So let's go ahead and head back to our slideshow, and let's start talking about sectors. So when we talk about a sector is just a portion of the circle. So when you cut up a pie and you have yourself a little slice of cherry pie or banana cream pie, whatever it is, one piece of pie is a sector of that entire circle. So before we start talking about sectors, let's talk about the area of a circle. So you guys should know this, area equals pi r squared. So let's go back to this same example. If my radius is 12, I can take that 12 and plug it into that formula. So the area equals pi times 12 squared, which is 144 pi. Again, I hope this is a skill you already possess, so I'm not going to spend too much time on it. Instead, if we want to change it to a decimal, just multiply by 3.14. And so we've got 452.16. So let's talk about an area of a sector. A sector is just a portion of the whole circle. So anytime you have any sort of round food like a pie or a cake or a pizza, and you take a section out of it, you've just taken a sector of whatever that thing is. So in this case, the sector is from A to C to B. It's that whole pizza shape right there. So if I want to find the area of that, let's just go ahead and use the same idea as what we did for the arc length. So if you remember that formula was the arc measure over 360 equals the arc length over circumference. Well, what we're going to do is we're going to go ahead and we're going to cross out the arc length and circumference and replace it with the sector area compared to the entire area of the circle. Okay? Hope that makes sense. It's still the same idea. This sector is a portion of the whole circle. So we figure out what portion it is by doing the arc measure over 360. And that will give us the sector area over the full circle. So let's go ahead and start plugging in numbers. So the arc measure is 45 degrees. The sector area, we don't know that, so let's just call it x. And then the full circle, well, we just learned in a previous slide that the area of this circle was 144 pi. So let's go ahead and take that 144 pi and plug it in. Now let's go ahead and make a little bit of room. Let's do some cross multiplying. So 45 times 144 pi is 4,480 pi. 360 times x, 360x. Divide, and you get 18. Well, you should get 18 pi. All right, let's go back to that. Yeah, that should be 18 pi, which would be 56.52 units. Okay, let's do another example. Let's say you got a pizza. What's the area of a slice of pizza from a 14-inch large pizza? And let's just say that this pizza is cut up into 6 slices. Well, let's go ahead and use that formula. Let's see, if we have a full 360-degree pizza and we cut it up into 6 slices, each central angle should be 60 degrees. So we'll go ahead and plug it in there. The sector area, we don't know that. We're trying to figure that out. And then the circle area, what's the area of the entire pizza? Okay, how much surface does that pizza cover? Well, if the radius is 14, well, a 14-inch pizza, that's the diameter. And so what we have to do is we have to take that and cut it in half. The radius is 7. And I just realized that, and I made a mistake when putting this slideshow together. It shouldn't be 196 pi. It should be 49 pi. Okay? So if you're taking notes, which you should be, go ahead and scratch out 196 pi and make it 49 pi. So let's make a little bit of room. And something else that you can do to kind of make things a little bit easier is if you want to reduce that the 60 over 360, you can, and just make it 1/6, which makes sense because we have 1 out of 6 slices. So cross multiply, and it should be 49 pi equals 6x. Divide by 6, and let's see, so 49 divided by 6. Okay, we get 8.16. All right, so there's about 8 square inches in that slice of pizza. I was doing this earlier, and I was just thinking, 32, that's an awfully big amount of pizza just for one slice. So I'm glad I caught myself before you guys saw this. All right. So let's go ahead and do a few more examples of that and see if we can do a better job than what I just did with that pizza problem. Okay, so let's take our formula. We'll take the central angle, which is 60 degrees, over 360. Our sector area, we don't know what that is, so we'll call it x. And then the area of this, we do pi r squared. So 10 squared is 100. So 100 pi. Just because I'm doing this in my head, I'm going to go ahead and reduce that fraction. So 60 over 360 is just 1 over 6. Cross multiply, and I get 100 pi equals 6x. So divide by 6. You get 16.67 pi. But the instructions want us to round to the nearest tenth. So I will do that times 3.14. And I get 52.3 square inches. Anytime we deal with a sector, we're dealing with area, so make sure your unit is squared. Let's go ahead and do the same thing on number 14 here. So our area, our angle is 150 over 360 equals x over, let's see, 3 squared is 9, so 9 pi. I'm going to reduce that fraction and make it, see, they reduced by 30, so 5 over 12. Cross multiply, I get 45 pi equals 12x. Divide by 12. And I get 3.75 pi. So 3.75 pi times 3.14. I get 11.775. So that should round to 11.8 meters squared. And that's the area of that sector. Hopefully this wasn't too bad. The main purpose of this is for what we're going to do in the next section on geometric probability, and you'll find out what's going on with that. So if you guys have any questions, please feel free to ask me either in class or email me, and I'd be glad to help you out in any way that I could. So hopefully this lesson wasn't too bad. Hope you guys have a good one, and I'll see you real soon.